calculations involving unit cells and their dimensions. The major calculations are involved in finding out the most important property of these unit cells or crystalline solids, which is their density. Now that this simple important property, which is called density of a unit cell or of a crystalline solid, gives us a very valuable information from which we can easily find out what exactly their unit cell's dimension can be. The density, as we know, is mass upon volume. So the density of a unit cell, for volume we will have definitely A cube, and for mass definitely we will go for the molar mass. But in order to convert it into that molecular mass into molar mass, so that we can have the answer or the unit of the density in terms of grams per cubic centimeter, we need to what? Divide this by Avogadro number. But exactly to find out the mass of the unit cell, we need to know how many such particles will be there in one unit cell, so we have to multiply this by Z. So this is what is the formula is, which is normally represented by Zn A cube into Na, Avogadro number. This is what is the formula is, and it is usually expressed in terms of grams per cubic centimeter. Now this property, important property, gives a very valuable information regarding the dimensions of the unit cell. If we know the density, which can be easily determined by the different techniques which are used in the physics, like pictometric density or X-ray crystallography density, we can find out exactly what is the edge length is, or we can find out what is Z is, and if we know the Z, if it is 1, we can say that the cell is SCC or primitive type of unit cell. If it is 2, we can say it is a body centered unit cell, and if the Z comes out to be 4, we can say that it's an FCC unit cell, it is having a cubic close packing. If we know the A, we can find out exactly what A is, and if we know the Z, from A we can find out the radius of the particle. So all these important dimensions which we need to know about the unit cells, we can easily be determined from the simplest formula and the simplest property, which is the density of the unit cell. Let us understand from an example that how the density can give us a very valuable information, or how the different very valuable information regarding the dimensions of a unit cell can be used to find out the density of a unit cell. The numerical is silver 108, which is its atomic masses, forms CCP lattice and has an edge length of 108.6 picometer. Find its density. So the information is given to us is in this form, that the Z, since the silver forms CCP lattice, so it is 4 because CCP forms FCC unit cell, which is having Z4. Second information, the atomic mass is 108. 108, it will be grams per mole. Then the edge length. Edge length is given to us in 408.6 picometer. We can write it as 408.6 into 10 to the power 12 centimeters. Sorry, it is pico is meter, so it will be 10 to the power 12 meters. We can change it into centimeter, and then we can write out it will be 4.086 into 10 to the power minus 8 centimeter. So now we know A, Z, M and Na. We already know it is always this 6.022 into 10 to the power 23. So now we know the formula, it's Z M A cube into Na. We know Z is 4, mass is 108, A cube is your 4.08 into 10 to the power minus 8 cube of this into 6.022 into 10 to the power 23. So when we solve this, what we get is 10.5 grams per cc. So this is what is the density of the silver is, and this is how we can use the information which is given to us in finding out the density of the crystalline solids. Let us see another numerical to understand that how we can find out the very valuable information regarding the dimensions of a unit cell from a density numerical. The copper crystallizes in FCC unit cell with edge length of this much 360.8 picometer and has a density of 8.92 gram per cc. Find its atomic mass. So we are already given that the Z for this copper will be 4 because it forms FCC unit cell. Its edge length is already given to us as 360.8 picometer, which as I have described you can be written as 3.608 into 10 to the power minus 8 centimeter. And the density is already given to us as 8.92 gram per cc. What we are supposed to find out is its M. Now we know the formula, it's Z M A cube into Avogadro's number. Let us put the values. It's 8.92, Z is 4, M we are supposed to find out. It's 3.608 into 10 to the power minus 8 cube of this into 6.022 into 10 to the power 23. When we solve this, what we get is M to be approximately 63.1 grams per mole. So this is what is the answer of this numerical, and you can use this very valuable informations regarding the unit cell like this, and you can put the values in the density formula and you can get the answer.